Hello everybody and welcome to my presentation for Robotics 437, a class on robotic navigation taught at the University of Advancing Technology. So for this assignment, I had to write code and implement it on a robot that will allow the robot to move forward, backwards, spin left, spin right, turn while moving forward to the left, turn while moving forward to the right, turn while going backwards to the left, and turn while going backwards to the right, all by using an infrared remote control. So it was pretty cool. I love doing it. But before I was able to do that, I knew that I had to figure out the hexadecimal um, values for the button presses that are on the infrared remote control. So I wrote this little snippet of code here that allows us to do that. And what I'm going to do right now is I'm going to upload the code to the car. Okay? And what this does is, well, hold on, let's let it upload here. Hold on 1 second. Yep, I screwed that up. Let's do this again. Sorry about that. I had it switched over to send instead of receive. So let's do this again. So let's upload this code. Hey, it's rock and roll, right? It's never perfect. But anyway, uploading the code. It's done uploading. So as you can see in your serial monitor, if I press a button, it will give us a hexadecimal code. So ignore the function decode, depreciated stuff. It still works. I tested it out. So here's the thing. So if we press forward, we get FF629D. That's the hexadecimal code. Now, if you keep it pressed, you'll notice you'll get 8 Fs. Well, that code represents that it's repeating the last hexadecimal value. Okay? So if we switch it to the right, we get another hexadecimal code. Reverse, left, turn left, go reverse, left. As you can see, it's picking up the code. Okay, stop. So, but if we keep pressing it, it gives us this repeat code. So, and if you can move too far away from it, it's going to mess up. Anyway, this is how I was able to determine what the hexadecimal values were for each button press. It's very important that we have these because we won't be able to assign them to functions and be able to have the robot move using our infrared remote control. So that was the first thing I needed to do, and I did it, and it works great. And I will upload that code for you, professor, so that you can actually, if you want to, give it to people so they can use it. But moving on, so that works. Here's the main code for my robot. So I had to do a lot of research on this because the robot was actually one of these pre-built kits, as you know, and I had to find out, what pins were what. It wasn't too difficult because the manufacturer gave us, sorry about that, wrong one, gave us schematics. So I used these schematics extensively while designing the code of this robot. Here is your H-bridge right here. Here are the 4 motors right here. Here is the device that is going to, or part of the H-bridge that allows the thing to move. And because of this, I was able to determine what pins were being used for what. I was also, right here is the IR module. So I was able to get the pins and the wiring diagrams for it. So I didn't really do my own wiring diagrams. I figured that would be overkill because these were made specifically for that. I know how to read them. I do know how to make them. You've seen me make them before. And if you want, I can do that, but I figured it would be overkill. Why do that when we have perfectly good schematics to use in the first place? And part of being a robotic engineer is being able to read other people's schematics, right? Right. So that's my logic with that. So I also have other diagrams of the different components that are with the robot, and they prove to be invaluable. So just so you know that. Now moving on, this is the code for my robot. So the very first thing I did was I wanted to write some test code to make sure that I was able to make the robot actually move. So I wrote all of these little functions here, okay? Forward, reverse, pivot right, pivot left. You get the idea. Turn right moving forward, turn left moving forward, reverse, reverse and stop. So first thing I had to do is figure out on the H bridge what pins were what. So with this particular H bridge, it basically controls either side, the left side or the right side. There's a total of 4 motors, but the 2 left motors will move in tandem, the 2 right motors will move in tandem, and that is because they only have one input, one pulse width modulation, and one standby. You have one standby that is being shared by all 4 motors. The standby will turn the motors on and off. So high is on, low is off. Pulse width modulation A and B, that's going to control the speed of the robot using pulse width modulation. 0 to 255, 255 being the maximum value for the highest speed, 0 being basically nothing. So we can control the speed of the robot, the left side and the right side. And then you have the motor pins that are going to, you can set these to basically forward and reverse. High is going to be forward, left is going to be reverse. And I define these at the beginning of the program because if you define them, it uses a lot less memory. So I also do a constant integer, call it IR pin. I put this to set this to pin 9. This pin is used for the IR receiver. This was hard coded into the robot because we're using a shield or a hat or a backpack or whatever you want to call it that sits on top of the Adreno, and I had to figure that out. We are using the IR remote header file from the IR remote library, which is pretty neat. It's pretty intuitive and very easy. I create a IR receiver object, basically IR receive. I call it IR receive, and I attach it to the IR pin, which is pin 9. So basically that sets up the IR receiver. The decode results right here, this is a function that will basically get the hexadecimal values and print them out for whatever you need. I have an unsigned long integer called last code. I use this as a variable for a placeholder because what happens is like I said, when you press these buttons, sometimes you get an 8-digit F code, which is basically saying that the previous code is repeating. So what I do is I put that code, the very first press, into this unsigned long integer and store it. So the robot knows what we're trying to do. If we're still trying to move forward or backwards or what. So we know that. I do have it set up so it will print out to the serial monitor. Right now I don't have any other type of monitor to use. I'm thinking about using a small LCD screen that uses either I2C or the SPI bus, the SPI bus, that would work. Maybe I can use UART, but there's a lot of pins being used on this already, so I'm limited on what I can do. Anyway, moving on, we set the enable pin for the IR receiver, so it starts, and it starts reporting to the serial monitor. I set all of the pins that are used by the H bridge and the motors to outputs. Then the main loop, if we get a button press, that's what this means. If we get a button press, then we're going to report it to the serial monitor, and then resume it. So basically, we get it, and then we resume. Basically, so how it works is you press the button, it records it, and then it looks for another button press. So it also, in the main loop, we're also calling the IR mode function. The IR mode function is the main function of the program, and it basically has a bunch of if statements that say if you press this button, you're going to do this. If you press another button, you're going to do that. Kind of simple. Out of the loop and on the bottom are our function prototypes here. Basically, I have, your typical forward, reverse, left, right, and all that. So how we do this is we analog write to the pulse width modulation pins, set them to a value. Right now I got this one at 255 for both for moving forward. We set the digital write for the A and B pins to high, which means that they are both going to be moving forward, and the standby is high, which means the motors are going to run. So in reverse, let me do this. I was actually experimenting with the different speeds because there's a lot of torque with this robot, and it can go pretty fast. But I'm gonna show you that. So I'm gonna put the speeds back to the highest. So in reverse, we basically digital write low to the A and B pins for the motors, which is going to make the motors go in reverse. Okay, that's how that. Now the pivot right, we set the A motors to high, the B motors to low, which basically is kind of it's kind of acting like tank treads with this because, like I said, the two left motors and the two right motors are tied to each other. So what we're doing here, in order to spin it right, we have one set of motors set to forward, the other are set to reverse, and it pivots. It pivots around the z-axis. So I mean, it literally spins around the z-axis to itself. There's really no forward or reverse movement to it. Pivot left does the opposite, and pivots to the left. Now, to make the car turn in a forward fashion, for turn right or turn left, how we do this is we differentiate the speeds between the left wheels and the right wheels. And I learned this by reading that book that is for the class. So if we basically slow down one of the motors, we can control the angle of attack and make the robot turn at a specific degree. So for instance, I have one motor running at full power and the other motor running at half power. And by doing that, we're able to make 90-degree turns pretty fast. And I do that for the forward left and the forward right. Okay. And then I also do it for the left reverse and the left right. We just kind of reverse the numbers on the motor pins, and then we set them to high to move forward and low to move in reverse. That's how we do that. I also have a stop robot function that's actually quite valuable because the way the code works, it is going to run until you hit stop. So that's that. So the main function, the IR mode function, is basically the function that gets the inputs and translate that into movement. So what we do here is we say if the IR receive decode is getting some kind of value, we're going to check to make sure these values work. Let me clean this up a little bit. I just got done writing this, so it's all good. Okay, so we have a bunch of if statements that say if the value equals forward, this is the forward hexadecimal value, we're going to basically move forward. Okay, if it moves forward and reverse, left, right, and all that other stuff. There is something I do need to put in here really fast that I didn't. I want to do this really fast. So we're going to say if results.value, hey, you're getting the code along with me, equals 8. Then we are going to do this. Results value is going to equal last code. So that basically is going to set the result value to the last button that was pressed. Remember, the the 8 Fs mean that the button press is repeating itself. So we have to be able to tell the robot that that repeating code is going to be the last one repeated. So in other words, if I press forward and we get the hexadecimal FF629D, it's going to move forward, but then it's going to get a bunch of Fs after that if we keep it pressed. So we need to tell the computer or the robot that those Fs are still meaning the last input, which would be forward. And then it keeps checking, so if there's a different press, it'll do that. And that's why we have the result values equals the last code. So we know that it's going to be recycling this code, basically. That's how this works. So they're all there. And then I delay for 50 milliseconds just for debouncing reasons, just in case if there's something that's going on with this button that is bouncing up and down. And then we use the IR receive, resume. So basically what we do here in layman's terms is we get a button press, okay? We delay it for 50 milliseconds and then we resume it looking for another button press. So if it registers as 8 Fs, we know that we have code in there that's going to say those Fs mean actually this hexadecimal number. And then it searches through all of the hexadecimal numbers that we can use to make movement and executes the code and repeats itself indefinitely. And that is the code. Okay, so I will compile it in front of you to let you know that this is working good. It's done compiling. I will upload it to the robot now. And we are uploading it. It's going to take a few seconds. And we are done uploading. Now I will demonstrate the robot in action. Thank you guys very much. I know this was a little long, but it's well worth it. Okay guys, here's the robot. Here's the remote control. Just to let you know, I had to modify the code a little bit. I had to take out that last little bit of code where I said FF. It was producing some unpredictable results. So we're just going to go with what I got here. Okay, so you ready? I'll press forward. Okay, so it goes forward, stops. I'm going to press reverse. Stops. All right. So now we're going to press left. Well, this remote's a little on the cheap side, but it'll work. Come on now. Come on. There it goes. All right. So pivot to the left. And stop. Come on. Stop. Okay. Pivot to the right. There it goes. All right. Come on now. I still, I still got to work out some of the bugs because these button presses should work a lot easier, but they're not. Okay, so let's go forward and reverse. There it goes. All right. Reverse. I'm sorry, that wasn't forward and reverse. That was left and forward. I'm going to go reverse and forward, or reverse. I am all thumbs. Reverse into the left. There you go. There's that. All right, let's get to stop. Please stop. Thank you very much. Okay. Now we're going to go forward and right. There it goes. Whoops. Let's see if I can get it. There he is. Alrighty. We'll stop it. Okay, he stopped. All right. And we're going to go reverse into the right. Come on now. Come on. It's this cheap remote. So, but it works. Look at that. So, come on. Stop. So we got all the movements: forward, reverse, pivot left, pivot right. We have forward, left and right, and reverse, left and right. So yeah, this is cool. Lovely. Oh, don't mind my mess. Okay, you can stop now. Very good. Anyway, there you go. So it works.